Okay, so we're gonna continue with the big bad physical developer. Not saying this because the physical developer is really hard to do. It gives good result though, but it's really hard to do. So I'm gonna go almost the same way as I did with the already. So you're gonna have kind of a history part and how it works, and finally how to do it. So again, we go with the treatment for porous surface where we had the already over here, but everything is the same. You got the nidrin, DFO, and Dandion, already magnetic powder again, if you wish to try, and the physical developer. And when you go on wet porous surface, you got again the multimetal deposition, the already, and the physical developer. So history, the history of physical developer is more dark. It's harder to find something into books and all that stuff to know where it origins. Um, what I found is that physical developer was developed by the Atomic Weapon Research Establishment and the UK Home Office Scientific Development Branch. That kind of a, I don't know if that was complementary or separate research that just bring together the result, but well, that's not clear enough. The technique was introduced into the manual of fingerprint development technique, probably that you got one at your laboratory. That was at that time edited by Morris. There were several attempts to simplify the process over the years, and well, the result were so well, not good result at the end of the day. But some people find a way to make it more stronger, more stable, and that's the recipe that I'm going to show you there. The last formula developed by Ramatowski from the U.S. Secret Service is pretty strong. So that's the one I'm going to show you today. A lot of work has been done to simplify the process. As I said, the results were poor. In those work, there's an attempt to acidify the acid pre-wash to help to remove the calcium carbonate. Calcium carbonate is used to link all the fiber into your paper and to whiten the paper to make sure it's white. So there's change into the Semperonic N that has been used in the past to the Twin 20 that is proposed by the U.S. Secret Service to improve the stability, and that's pretty cool stuff because actually got pretty good result with this. So the physical developer, what it is, it can detect fingerprint on wet and dry porous surface again. It's based on oxidation reduction reaction. Again, I'm going into your high school chemistry today. Could be used to develop salt trace from shoes on paper if you're more in a northern state. In southern state, that's less used because actually you don't use salt on your road. But we did, so that's the point. You can develop very old fingerprint. That's important because actually it don't target the lipids itself. So that's important. You're going to see why later on. It can detect the fingerprint not developed by the Orido, or actually developed without rich detail. And it develop fingerprint. The fingerprint develop is more stable and it's going to stay visible for a long period onto your paper, unless the denidrin, for example, or the Orido who's going to fade over time. So that's why those techniques use a lot of photograph. At least I propose you to photograph your PD result even if you think it's going to stay longer. But well, at the end of the day, it's supposed to be there for a longer period. So, the bad side of the PD. There's a lot, eh? That's a destructive technique. That's the one you should use at the end of all. After you did the physical developer, that's the end. You couldn't do anything else. That's important. That's really time consuming, and I'm not talking about only the treatment itself. Just doing the chemicals is pretty long. You're gonna see in the lab. The chemicals is really expensive. That's a bad point. The application is complex again. You should monitor the development during the process. You couldn't do something else in the meantime because actually you're gonna pass through your fingerprint and you don't have any result. The acid wash pretreatment render the paper really weak. So if you use kind of a plier that is a bit kind of needle point, you're going to pass through your paper in a second. Large quantity of glassware needed. Very clean glassware. And when I said very clean, you're going to see later on, that's brand new stuff. And we're going to have to pass 3 times with distilled water in it before we just put the chemical in the back. So that should be clean, really. And that's really dirty. So if you got kind of a nice laboratory, that brand new countertop and all that stuff, it's going to be a messed up after the end. So that's an example of fingerprint with the PD. So the results are pretty cool. You got good results, a good rich detail. That's not the problem. It's pretty long though, but it works well. It goes into 6 steps. Actually, I have only five tray, but that's the point. First, you just rinse it into distilled water. Then you do your acid pre-wash. Then you rinse again. You got your physical development treatment. You got a fixed solution, and then you dry your paper. So a lot of glassware needed for this. Okay, preparation of solution. First of all, the first thing you should do, and we will do it in the lab, and that's really important, you must make the verification of your distilled water. That's important. You must make sure that your distilled water is not corrupted. So you had some crystal of silver nitrate into a little amount of water, and you see if the water stay clear, your distilled water is okay, no problem. But if it become white milky material form at the bottom of the container, your distilled water must be changed. I hope it's not the case. So that's really important. And you always must use plastic plier and glassware. You don't want to use any metal in this, any stainless steel and all that stuff. That's really important also. What you must remember, you always put acid into water, never water into acid. Putting water into acid gives an exothermic reaction, heat production that could cause an explosion, and that's real. So keep in mind that acid and water, yes sir. Water and acid, stupid. That's easy to remember. So here we got the preparation of solution. So we got a lot of solution that we must prepare at the beginning, and then we mix a lot of them together, and then we got the result. So that's complicated a bit, but it works. You got a redox solution. I won't pass through all the numbers on this. Then you got the detergent solution where we use the twin 20. The detergent solution use also the endodiethylamine acetate. This chemical is really expensive. That's the one that costs a lot of money. And afterward, this detergent solution, it takes about 30 minutes just to mix it together. So we're going to start with this at the beginning of the lab, let it mix together and do something else by that time. The silver nitrate solution, that is quite simple to do. You got your malic acid solution. I know that a lot of laboratory are using different kind of acid solution. I know some are using acetic acid solution. In that case, we're using malic acid. That's the acid pre-wash bath at the beginning of your treatment. And you got the fixed solution that is more kind of a rapid fixer stuff, just like we use with pictures in the whole time, the Brian time. Oh, sorry. Just kidding, Brian, you know. Okay, great. And the PD solution itself, it's a mix of redox, detergent, and silver nitrate solution itself. And you should use this solution as soon as it's prepared, because as soon as you prepare the solution, it starts to react, and you're losing the power of your solution. So after a while, it don't work at all. Procedure is pretty simple. Well, long, but simple. You soak your document into the distilled water for a time of 2 to 3 minutes, and then you remove the document and drain it, place it into the pre-wash acid treatment. You keep it immersed as long as you got bubbles forming in the solution. That just get rid of all the calcium carbonate that you got into your paper. Well, not all, but a lot of them. So the calcium carbonate won't react directly with the silver particle, so you won't have only a black sheet of paper. So that's important. Then you remove the solution, you drain it, and you soak the solution into the second distilled water bath for 2 to 3 minutes again. And you remove the document from the water bath, drain it. Don't remember that between each tray, the plastic plier must be soaked into distilled water just to remove the solution from the bath before, because remember, it should be clean. That's important. And finally, we place the document into the PD working solution, and we must monitor very closely that result. If you don't, you could lose lost fingerprint. If you use the Alredo before the PD, pay close attention to the site where the Alredo has stained the paper, since there's greater chance of finding fingerprint here. That's what I was talking later on. When the development of the fingerprint is sufficient to your eyes, you remove the document from the PD solution, and then you immerse it into your fixed solution for 2 to 3 minutes to stop the reaction, and you let the document dry to open air. So that's a long journey, eh? How it works? Well, the fingerprint development technique is based on oxidation reduction, just like I said at the beginning. The oxidation reduction is a spontaneous reaction where there's an electron transfer from one atom to another one. The reaction where oxidation and reduction take place simultaneously. So you couldn't take those two reactions aside. They must be both together in the same reaction. If you try to do an oxidation on one side and a reduction on the other side, it won't work. So you got the neonization at the beginning, so you got your silver nitrate and ferrous ammonium sulfate that become silver ions and ferrous ions. And you got the oxidation reduction reaction, where the chemical reaction, where we lose an electron. So we pass from the ferric acid to Fe2 plus to Fe3 plus. And then we pass for the reduction, the chemical reaction, where we gain an electron, where we pass from silver plus to silver solid silver particle. So the equation is right over there. So that was just for you to know, because actually you don't need that reaction to make it work. But that's important to know where it comes from, I think. Hope you think also. During oxidation reduction, the chemical compound that give an electron is called a reductant, and the one that receives the electron is called the oxidant. And how does it work on a fingerprint? So you got, again, your latent fingerprint cross-section. You got colloidal silver particles that are pretty small at the beginning of the creation of them, and then you got bigger silver particle. So let's see what's going on with this. So again, you got your fingerprint ridge with the lipophilic part in the middle and the hydrophilic part outside in the paper at the bottom. And now we get all the colloidal small particle of silver that goes on, and they don't goes in, they goes on top, and they goes on top of fingerprint and the paper, both, and that's important. So that's why when you got fingerprint, with physical developer, you got to see that your paper is not white at the end of the treatment. It's going to be light gray, if not all gray, but if it's all gray, it don't work but well. Usually it's light gray. And finally, you got all the bigger silver particle that came, and you got an electrostatic forces that form with the reaction between the colloidal sphere particle of silver and the fingerprint. That's not really clear how it makes that kind of forces, but actually there's something there that attract the bigger silver particle that just goes on the fingerprint. So you're supposed to have a darkened silver fingerprint on a light gray paper. When should I use PD? The PD should be used again on dry and wet porous surface. The PD should be integrated into your sequence after the Alredo, even with the wet porous surface or the dry porous surface. Again, you can see diethylnidrin Alredo PD or Indandion Alredo PD. And with the wet porous surface, we go again with the same thing, where we put the PD after the Alredo, and that's pretty important. Physical developer after treatment with Alredo, we already seen those pictures. So in conclusion, we could see that the physical developer is a good technique for wet porous surface and dry porous surface. It works. We should practice the physical developer technique in order to be able to use it in a case where that's the big part. Do we have the time to make some trial with this and try it at the lab? We should take the time to do it. And that's probably why sometimes some people just don't want to use the PD because they don't have the time to practice it. That's important to take the time to practice it at the lab. The physical developer is especially good for very old fingerprint, and that's a good point to take into account. The physical developer should be used at the last and final technique because it's destructive, and that's really important also. So do you have any questions? Yes.
I have a couple, sorry. We've had situations where we can't get the pH in the acid pre-wash, there won't be any more bubbles, but then we'll put it into the solution, it'll turn black. Do you have any thoughts on?
I know that Romatowski did a nice article in the GFI about using an harder pre-acid wash bath, where you use a 25% acid with acetic acid. That's kind of mixed with water and acetic acid, and you keep it at 25% degree, not degree, but 25% concentration. And actually, that's gonna weaker your paper a lot, but you don't have any background on it. Right. That's really hard. That's a hard treatment, but if you got kind of paper, you know that type of paper, you got big problem with malic acid, for example, maybe you could use that kind of acid bath before if you wish to try it and got some result. Because usually when you're at the PD, you're at the last step that you could use, so you don't have anything else you could do.
Right. When you QC PD samples, how do you get a good lipid profile, something that will work? Sometimes what you use just our...
I would say do your fingerprint a year before.
Okay.
The fingerprint with the PD is going to be much better if it's older. So if you prepare all your sample at the beginning of the year and use it only the year afterward, you're going to have better result for your QA testing. That's going to be the better way to do it, I think, because otherwise, I don't know why it don't react as good as a whole fingerprint, but the fresh one seem to have big problem to develop.
And what is the lipid profile that stays on top that it's targeting? You know how you said that.
Actually, it's not really only the lipids. When you go into your PD, your fingerprint, you got the lipids, but you got the squalene and the wax and all that stuff that goes into your lipids. The Alredo stained the lipid part of it, but actually the lipid goes into your paper. But the physical developers stay more into the squalene and all that stuff at the top of the fingerprint. So that's why you could get some ridges where the Alredo don't have any. So that's the point. Because those parts are not soluble at all, and they don't go into the paper either. So it stay at the top.
Okay, I have one more question. I'm sorry.
No problem.
If the silver doesn't come out in the solution, is that a detergent issue? Like sometimes we'll have a solution where we can try and nothing comes out. It's not even like the edges will turn gray. What's that?
That could be the detergent. Actually, the detergent prevent the silver to transform into colloidal sphere too fast. So actually, if you only got colloidal sphere, you have too much detergent, for example, and endodecinnamon acetate, the concentration is not good enough. Could happen that your spherical silver particle won't grow enough to be bigger to make the electrostatic forces to go on the fingerprint precisely. So that's probably the case, but that's hard to do. That's hard to make sure. With the tween solution, Robert Romatowski told me that he could keep his solution for a while before it stopped working, and actually you don't have any problem for silver deposition with it. So and actually what we did on our side, we don't do a big batch like the U.S. Secret Service do, because actually they're doing it in big barrels, and that's crazy the amount of paper they could treat in a year. Actually, we're doing small batches and all that stuff. We got good result with it also. So.
You still use the bleaching solution at the end of processing that for stabilizing and like make the prints more.
Yeah, on our side we go more with a fixer, like a photography fixer. It works well, but actually I haven't used the bleaching solution yet.
Background lighter and increase the color of the print.
That could be interesting to try. I haven't tried it, so I couldn't answer you on this.
Stabilize the print as well.
Yeah. No, actually, we're using the fixed solution on our side, and actually that was a whole procedure that come from a long time ago, and that's the first time I heard about the bleach, so that's interesting to know.